Right, welcome back, calculus class. This, as I promised, is a differential equation problem. You can pause the video. This is definitely a complicated problem. Okay, now that you've paused the problem and are ready to see the solutions, hopefully you did well on it. Points will be kind of difficult to come by on this problem. But let's look at it. It says the first part, they give us the information. You've already read that. So it says, write an equation for the line tangent to the graph of h. Okay, so we start seeing tangent. We start seeing, okay, we need a point and a slope for derivative. Point and a slope to get the tangent line. So we're going to use the derivative here. And we don't have to solve the derivative. They gave us the derivative. dh dt is equal to negative 1/4 h minus 27. Now, this problem you're going to see, if you didn't catch it in the original portion of it, is a little bit different because if you think about how your derivatives are usually set up, it's usually dy dx, and y would be your range value. And then you typically have something in terms of x here. Well, you're getting your y value right here instead of your x value. So if right now you realize you did something wrong and want to change that, pause the video and you can change it. Okay, now that you've paused the video if you needed to, let's go. So it tells us that when time is 0, the temperature is going to be 91. So negative 1/4 of 91 minus 27. So it's negative 1/4 of 64. Which is negative 16. So that's going to be our slope for our tangent line. Now we use the point. So the point is y minus y sub 1 equals m times x minus x of 1. Of course, again, in this case, it's not y, but it is h. So we have h minus 91 equals negative 16 times x minus 0, or t in this case. So we get h equals to negative 16t plus 91. And they're interested in when the temperature is, or at time 3. So we have negative 48 plus 91. And when you do that arithmetic, you get 43. And again, you would want to write down your degrees Celsius. So this part of the problem right here in part A was worth it was worth 3 points. The breakdown you can find on the computer. It's on, again, this is problem 2017, free response question number 4. All right, let's go to part B for this problem. Part B for this problem says we want to use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature. So, again, we have that dh dt is going to be negative 1/4 of h. And then I'm going to say plus 27 over 4. Now, when we take this derivative, it may not be quite as easy as you think it is. Because, again, this is not our domain value. This is our range value. So the derivative here, d2h dt squared, is negative 1/4 dH dt. Now, what do we know about dH dt? Well, it's this. So we end up with d squared h dt squared is negative 1/4 times negative 1/4, and I'm going to write it like it was here originally, h minus 27. So this would be 1/16 of h minus 27. Now, they're interested at time 3. But the thing that they tell us in the problem is that this h value right here is always going to be greater than 27. So, for that very reason, you could say because h is greater than 27, we are concave up, because d squared h dt squared would have to be positive. So we're concave up. So if you're concave up, again, you wouldn't have to do this drawing, but if you're concave up and you've got a tangent line, no matter where that tangent line is on the concave up interval, it's going to be an underestimate. So this was actually only worth 1 point. This part of the problem right here was you had to have your work done, make a statement that you knew that this was greater than 0, so it would be positive, so it would be concave up, and then tell that it is an overestimate. Okay, now on to part C, and I cheated and did part C ahead of time because of the arithmetic involved, and I did not want to make a mistake because several of you have come to think of me as being perfect, and I wouldn't want you to spoil your opinion of me. So here we start off. Okay, they give us a dg/dt equation, and they tell us that it is negative g minus 27 to the 2/3 power. And they want a specific equation. Well, when they give you an original, or when they give you a derivative, and they want a specific equation from it, we're going to need to anti-differentiate. This is what is considered a differential equation. So you get 1 point here for separating out the variables. In fact, this whole part right here is going to be worth 5 points. So we separate the variables out, and this is going to be worth 1 point just to separate the variables. Get your g over here. I left the negative with the dt. It just ends up working out neater to do it that way. The antiderivative of g minus 27 to the negative 2/3 is g minus 27 to the 1/3, because you add 1 to it and then you divide by 1/3. But dividing by 1/3 is the same thing as multiplying by 3. On the right hand side, you get negative t plus c. All right, if you do not get any points, if you do not pass this point, if you do not consider this c value here. All right, from here, you again, they tell us at time 0, G, which is going to be the temperature, is going to be 91. So when we solve this out, plug in 0 here, we end up getting 64. The cube root of 64 is 12. I'm sorry, it's 4. 4 times 3 is 12. So we get C to be 12 here. So our equation, and you would need to write this out as an equation, is going to be this value here. This is the specific equation for this particular problem. Now, at this point right here, we are interested in, a lot of times, let me pause for a second. A lot of times, this will be the stopping point of a problem. But this is a special case in the differential equation problem where they ask about a specific time. So we need to go through and solve this out when t is 3. So First thing I did was I divided both sides out by 3, so I had negative 1/3 t plus 4. Then I took both sides and cubed it. Now, be careful in cubing this right-hand side because remember, you're cubing a binomial here. So it's just easier just to leave it like this because we're going to be plugging in a number and getting a number instead of expanding this out. So we get negative 1/3 times 3, which is negative 1 plus 4 is 3. 3 cubed is 27, and you have this 27 you brought over here to add to it. So you get the temperature for this one to be 54 degrees Celsius. So this is our fourth sample problem to look at. Tomorrow we're going to pick a few multiple choice type of questions to do, and then we will go from there. Thank you. Keep working hard, and hope to see y'all soon.